are always open source first. So we always go into contributing in the Apache way. It is always consensual and everyone is involved. We take the feedback from community and how they are looking at our work. So while working on any project or any feature, we always create pull request or start contributing from start itself. So even if someone from a different company or anyone from community can give feedback to us on that particular feature, how it is integrated with CloudStack.
We are an open source community, so we have CloudStack Slack. We have the CloudStack GitHub repo wherein users raise issues and have discussions. We also have the mailing list. So as a committer of CloudStack, I've been trying from my end to be involved and interact with the community through all these channels, alongside contributing by means of development to stay in touch with the community and constantly contribute to the community.
I joined the project a little late in that sense, so I was involved in the development phase. So my task was mainly around implementation of the existing scope and doing all sort of development work. I think it's a great feature in a sense that it gives a lot of flexibility to operators to add new integrations to CloudStack. Right now it is limited to orchestrator extension, but it can be in future it can also include different network plugins, storage plugins. So it gives the power in hands of operators or any developers who are not particularly into CloudStack development to bring in features to CloudStack in future.
This feature basically allows you to launch instances which have GPUs attached to them. One of the reasons this is now critical is because of the rise of AI workloads, right? With rise of AML workloads, we also need GPUs, which are kind of critical to get best performance for the large language models that we are running. There is actually no difference from the existing workflow. If you have GPUs in your lab, you can now basically, we have specific dedicated hardware now, so you can use that host only for GPUs. So it doesn't use host which has GPUs for your normal workload. So there is as such no difference from previous. People who are looking to run or train their own models, they will largely benefit from this because in public clouds you can get a GPU at and they're quite expensive and the cost adds up. So if you have a self-hosted setup like CloudStack, you can just get a GPU and integrate that. So I think people can also see a lot of cost savings here. Apart from that, you can also set up virtual workstations with NVIDIA's vGPUs as well. So that also helps you out there as well. I believe that in future there might be some specific cards which are not exactly GPUs but are more tuned for AI workloads. So we might see those on the future, and the way the feature is designed, I think we should be that they should also be able to easily work with CloudStack as well without any changes.
CSI driver is basically used for dynamically provisioning volumes for stateful workloads on Kubernetes clusters, and it has been developed to seamlessly work with both CKS and CAPC. Just to highlight, this was a project that was incepted by Apalia, taken over and forked by LeaseWeb, and now ShapeBlue has taken it forward to bring it forth to the community for wider usage and adoption, so that we can identify what better can be done to fix it. And when it comes to the Terraform provider, basically it's a infrastructure as a code. So you can codify deployment of resources and have a more reproducible environment being deployed for you. And it's identical basically. So you can have a dev setup, a testing environment, a production environment and have them completely reproducible, because you have a configuration file that will help you deploy all of these resources. And having this Terraform provider, it's constantly being improved, and we constantly fixing all of the issues being reported by the end users. CSI driver is officially out for use. It has been integrated with ACS 422. And with this, what's new is we've extended support for the CSI driver to support other hypervisors apart from KVM, which is Zen Server and VMware. Furthermore, now it's supported at project level as well. And most importantly, we've also provided support for volume snapshots, which helps in disaster recovery. One of the most required aspects in Kubernetes deployments would be to provide persistent volumes for the workloads running. And with CSI driver now available, you can have these volumes provisioned in CloudStack without any manual intervention. And I think that would be really beneficial for anyone using CKS. While we have APIs and the UI to set up and manage various resources in CloudStack, Terraform is mostly used by admins and operators to help set up CloudStack environments, more identical and more reproducible environments, basically, so that changing few parameters will enable you to deploy more consistent setups. Over time, we've seen increased usage of Terraform provider, and a lot of users have come back identifying the various missing support for different resources. And we've constantly been working to provide support for it. And with this, coincidentally, we've also been upgrading and maintaining the CloudStack Go repository. So 2 projects are being managed based on users' requests.
Most important thing that I learned is how different users or different use cases of features is seen by the end users. Sometimes as a developer we don't get the real idea how they are consuming the features we are working on, but I think that's the main thing, the larger idea, how for example, this extension feature, someone could be writing an extension for some orchestrator like Proxmox or Hyper-V, but then for a different company or different user, it can be a use case for a network plugin. So that's something I learned. Your work is done in your name. Although I am contributing the work that ShapeBlue is doing, but again, all the code is showing up on the GitHub or on the internet in my name. So I have that presence. I am responsible to represent my company or my work as an individual as well. So that's really great. I would say the next one, something I would working next, but I think all the features that I have been lucky to be worked on have been significant features for a particular set of users, maybe not for all, but yeah. So I would say the next feature I would be working on would be definitely interesting.
As ShapeBlue employees, we constantly stay in touch with the community, and we identify what the community is talking about, what are the pain points, and try to find a means to provide a solution for these topics that are being brought up. And we have our internal roadmaps that are focused towards addressing all of these issues brought up by the community. So I think ShapeBlue does a great job in trying to develop different features that the customers and the end users want.
Lately, it has been my 1.5-year-old daughter, so I would like to spend all my time with my family and my daughter.
Sometimes I like to work on my personal projects when I'm free, or watch some anime or play games.